everybody, Chris here, and in this video I want to show you guys a good example of splitting classes to improve reusability. So this is building directly on what I put in the last video, where I demonstrated using a player context resource as a good solid way of connecting nodes to other nodes that may exist in different scenes. They might not be existing in your main gameplay scene at the same time when you load everything. So how you connect them together is by having this intermediate player context resource. So in that example, I had the player, which had a health property, a take damage method, player context. It also had the kinematic movement logic for the player as well. So it had a lot of functionality in one single script. And then the player had a reference to the player context resource. So it could set itself as the player to trigger these events on. And so with the player, we had a connection to this player context resource and another connection down here to the player log. So that meant you didn't have to have a node-to-node wiring between the two. However, the player node has a lot of responsibilities. So kinematic movement. So as we develop a player for a game, it'll keep adding to this list. And eventually, this would become something called a God class, which will eventually become hard to reuse and hard to read. So what you might want to do, especially if you care about reusing your logic and not having to test twice, is you can split some of these responsibilities out to reusable classes. So in this video, we're going to walk through the example where I'm going to take the player node, I'm going to take this health, and we're going to create an attributes definition. So this is going to allow us to set defaults for stats like health and strength, and this is also loaded as a resource. However, we're going to need to be careful about that because resources, if you reuse the same definition resource in the inspector, they're going to be shared at runtime. So what you actually want to do here is separate it with a runtime data object. So that data object is going to be created for each instance of whatever object you're creating, players, or anything else in the game that's going to need your attributes. So this is also going to have health and strength, but the difference is that the player is going to create your attributes data with the attributes definition at runtime. So you could kind of think of it like you have this attributes definition, you might save it to your project as a resource, and then the player is going to be responsible for creating the attributes data. So this allows us to take the responsibility of health off of the player. However, then there's the take damage method. So how do we want to manage if an object is damageable inside of the game? So this would be where we'd add another class. So this is going to be another runtime component, DamageableComponent. And this is going to have a reference to the attributes data so that it holds all of the actual values for the attributes here. But the DamageableComponent is going to be responsible for taking damage. Now, we also need to emit events to the events log when the character or any object that is damageable takes damage. And we want it to be reusable. So like over here in the player context before, we had a player health changed event and a player death event. So if you use the name terminology player, then it's specific to just players. But lots of objects in typical games are damageable. So what you might want is to take this and break it into an ObjectEventBus. So that is just a fancy way of saying a runtime object. So these are ref counted. All of these orange are ref counted. You don't assign them in the inspector. They're created at runtime. And this is going to own object health changed and object death. Now what we've done with this is erased these events from the player context resource, and we've made this reusable for any object in the game. So now any object that you want to trigger the object health changed event or the object death event, you just need to add these components to it. So with this, you can create not just player node that's going to have attributes data at runtime that gets fed into a damageable component. And this damageable component also is going to have a reference to the ObjectEventBus, by the way. So with those two, when it takes damage, you can emit the events through the ObjectEventBus. So object health changed and object death when it takes damage, obviously. Then anything that needs to trigger off of those events, you can feed it right and with a reference to the ObjectEventBus. Okay, so now over here, instead of owning these, our player context, which I didn't do in the video, but I might rename that to player provider. But we have the ObjectEventBus reference. And now, in the same way as before, the player context can still be used by the player log to log when the player takes damage as connected to the events through this object event bus. So same as before, but now an object event bus that's owned here is a lot more reusable than just a player context that holds the events directly, because this can now go to anything else. So if we wanted to, it becomes very easy to be like box, which is some kind of node. Maybe we say static body 2D, it doesn't move. And then this is going to have a attributes definition, an attributes data runtime. We could say up here, this is editor. This is what you assign to basically load the defaults. So you create the data from the definition. This is going to have a damageable component. It's also going to have an object event bus because we need to emit those events. So you can see how this box, which is just an unmoving player, it doesn't need any kinematic movement, but we can reuse attributes data, attributes definition, damageable component, object event bus, all to make this box node through a components-based approach, and it becomes really reusable. So like in the same way, you could create a goblin enemy and it would pretty much use these same components. And of course over here, the player no longer does take damage. It still has a player context specifically for UI wiring. But of course, the responsibilities here have been split up a little bit with that object event bus, and the player log still works the same way. But we have all of this reusable work here. Now, the last thing I really cover in the video that we'll get into in the actual coding session is that when you're connecting, a player log through a resource, you have to be careful about that because these resources are shared by default. So let's say you have a multiplayer scenario. So you have multiple players. If they all share the same context resource, there's only going to be one connection to the player log here. So if you try to initialize your player context with 3 players, then they're going to be overriding each other and you don't know which player is actually being used here. So I'll show you guys a guard method that helps you see that you keep the player context 1 per player. So you know exactly which player is in the context so that you know which player is being consumed by your player log. So it becomes very easy to have 2 player logs if you have 2 player contexts. And then basically all you need to do is have a player 1 context, a player 2 context, and a player 3 context, so on and so forth. And then you can have as many player logs and as many player nodes as you want. So now that I've explained all of that, let's get into the actual coding session. Hello everybody, Chris here, and in this video I want to show you guys how and why you might consider extracting properties like health out of a player into a more reusable game attributes component. So one of the most essential reasons is because many different objects in your game are actually going to use those properties like health. So you probably have enemies in your game and you might have destructible objects. Those are all different types of game objects or entities. And you want to make sure that they all share the same logic so you don't have to rewrite and retest it every single time for each different type of game object. So we're going to be pulling this out to a separate resource. And that makes it so that you can reuse it as like a component for each different character that needs it. So let's go to resources, and I'm going to create a new resource. Let's create a new script. I'm going to make it inherit from resource, making sure I'm in C# here. And I'm going to call it, let's say, AttributesDefinition.cs. Create that. And since C# script coloring only seems to activate when you actually reload the project in the editor, I'm going to switch over to Visual Studio Code, click on Attributes Definition, and that's going to make it much easier to edit here. Okay, so I'm going to find the player script here, and we're just going to cut this bit, export player health, and we're going to pull that right into the attributes definition. Okay, so why is this a resource? It's so that we can edit it in the inspector. So if we use export here, that'll actually work for the attributes resource, and we can set all of our defaults, overriding the script default with our editor configured value. That's really important if we want to actually edit the defaults from inside of the editor. So just to kind of visualize how you might expand this later on, let's say that your game attributes, every character also has a strength value. So I'll just put in export public int strength, autocomplete that default to 10. So now we have 2 properties on our attributes definition resource. Okay, now that we have this, we can go over to the player script, and instead of having export the health, we're going to export let's say the public attributes definition attributes get set. And I probably want to rename this more to default attributes, because these are going to be the values that your game loads by default when you're not loading from a save state, but what the default scene initializes with. So your player starts the game, and this is the default for what they're going to have. So how much health do they have at the start of the game? Not necessarily loading from a save state. Okay, so we want to be careful here and just acknowledge that these are the values at the start of the game. Now, this is going to cause issues down here, of course, because we no longer have the health property. But I don't want to do default attributes.health minus equals damage, because then that would be changing the values on this resource, which might even be shared. So instead, what we want to do is make sure we have an isolated runtime object that will handle the stats. So I'll create another folder here, and we could call it something like data or runtime might be okay. And then we'll create another script inside of here. To save a little time, I'll copy the attributes definition into here. Let's rename this AttributesData.cs. Fix the names here, AttributesData. So these are the runtime data values for any object that utilizes attributes. We're changing the type here to ref counted. If it's ref counted and not resource, it'll only ever be a runtime object, so you have to create it at runtime in your scripts in order for it to be active. You lose the ability for export, so it's going to look like this. But this is actually a strength. We're separating the concerns here. So we're making sure that our runtime is going to be unique and never duplicated like a resource might be. So we're making sure that our runtime data is isolated, tied specifically to the player. And that is a strength in the long term. So let's go back to the player CS. And now what we need is that runtime object. So let's add in private, AttributesData. AttributesData. Okay, so now what we want to do is initialize the attributes data with the default attributes at runtime. So now we need to make sure that the attributes data gets initialized. So we'll do, I actually want to turn this into a property here. And then we want to make sure that down here, we'll do the ready function. And then on ready, we're going to initialize the attributes data from the default attributes. So let's say public void void underscore ready. And we want to create a new attributes data. This is going to be equal to new attributes data, and we're going to pass in the default attributes to a new constructor we haven't written yet. Okay, so let's jump over to attributes data, and we want to create that constructor. The reason for that is it just makes it a really quick, easy place so that we can convert the one type to a runtime copy inside of the attributes data. So we'll do public attributes data, and we're going to pass in the attributes definition like this, and we'll say health equals definition.health. So this defines our defaults in the editor. When the player loads into the scene, we load those defaults to a runtime attributes data, and then this is now our active. It's also specific to this instance of player because we load it each time per script. So this attributes data is never going to be shared or copied with any other player in your game, which is important. We want to make sure that's isolated so that, you apply 10 damage to one goblin. It doesn't apply 10 damage to all the goblins. Now that this is the runtime, and we might even shorten this, I'd say, to attributes. I think that might be a little easier when we come down here. And then now instead of applying it to the health property, which no longer exists, we do attributes.health, and then we can copy that down here one more time, attributes.health. Now here we're getting an error because it says that we can't use the setter because it was made private, which is correct. If we go to attributes data, the set is private here. That's because of the copy pasting. But since we do have a need to set it from an outside source, I'm going to drop that. And you might also consider dropping it for strength and any other properties you want to change outside of here. Essentially, if it's marked private, you can only change it from an inside script. So if you wanted to change it from an inside script, you need to create other functions to change the stat inside of this script, not from outside scripts like player. Okay, so that clears up our errors. Okay, so if you go back into the Godot editor, you build it, everything looks all right, then you should see the default attributes pop over here as a resource. Okay, so if we click over here, we can see on the default attributes, it's allowing us to assign any resource. That's because I forgot to assign the global class attribute. So up here, right above the class definition, we put in global class with the square brackets. Go back to Godot editor, compile, and now we can click here and there'll only be one option. So we can create the attributes definition, and you can see the defaults. So whatever defaults we want for our player or any other object, we can just set those here. If you want to save it and share it between multiple different scenes, you can right click or do save as into, like, let's say characters and player default stats, or maybe default player stats might be a little better. Save it there. And there you have a referenceable resource. Now, you don't have to do that. If your scene already includes this just configured in the editor, then that's fine. It'll stay there. It's just going to be directly tied to that scene. So if your scene deletes, your default stats also delete. And that might be one reason you save your resources to the project, but it depends. So at runtime, it's not going to be modifying this resource, but the data object we created behind it. Just for debug purposes, we might want to go into the editor one more time, and where we have attributes data, and we might want to say something like gd.print and just say attributes data initialize. Okay, that will just tell us how many times this actually occurred during our game in the console, and we'll compile and run. Okay, so now when we run the game, and I do the key presses from the last video, where every time the key press event goes down or it's released, it's going to deal 10 damage to the player. We see the player's movement direction as well. So each time does 20 damage as long as we press and release. So that means 5 times, and the player is going to die. We can see that from the action log down here. Now, if I had skipped the resource approach, let's just duplicate the player a few more times. So they're all sharing the same logic. And we had used a resource and not initialized it to a separate runtime object for each player. Then what would happen is we'd move these players. You can see the attributes data initialized 3 times there, separate for each object. And we'd do like up, down, left, right, and it would subtract from the same health values. So it's very important to make sure that you have one set of stats per runtime game object or entity, whatever you want to call them. And now it's applying all of that event logic to each one individually. So they'll all die at the same time with the same number of key presses as before. Now, if we wanted to add a completely different type of object to the game, like let's just say, hypothetically, we have another, let's say it's a static body 2D. We'll say it's a box, or if I want to be more specific, a destructible box. And then we right-clicked here and attached a script. Let's say it's GD script. We have destructible box. Well, it inherits from static body 2D. Let's create that, open that into the editor. And I'm going to move the script here, of course. So let's say this. So right now it got put in the levels folder. I'm going to move that, I think. So let's say there's a objects folder. Go back to the editor. It's usually better if you move scripts from the editor because it updates all the references automatically. So we want to move this to the new objects folder. Let's right click on the scene. I'll save that to the objects folder as well. And then let's go into here. And then we can reuse the logic from player CS in here and kind of do the same thing in destructible box. Now, one extra layer of abstraction I might put here is to make a damageable component. So this will use attributes data and will reuse the take damage logic so that this can move out of the player as well. So let's say we have a new folder for components. We're going to make a new file, DamageableComponent.cs. Because this is going to use Godot, and we'll say public partial class damageable component. This is going to extend ref counted. So for the constructor here, I'm going to make sure that we take a reference to an AttributesData attributes. Okay, and we need that reference there so we know what we're applying the damage to. So let's say private attributes data attributes get private set. Looks good enough to me. And we'll pass in the attributes from the constructor. We can go to player, move this block over here into DamageableComponent like so. And well, this will require a little bit more changes as well, because the player health changed is based on the player, but we want to make that more of a universal event too. So, okay, that's fun. We'll go ahead and fix that too. So let's say inside of here we have a event. Let's say inside of here we have an events folder, and then we're going to do a new file. I'm going to call it ObjectEventBus.cs. So the point of this is going to be where we have events that apply to any kind of object in the game that has typical interactions like, oh, the object died or was destroyed. So that would apply to players, NPCs, and destructible objects. So we'll have like using system, because we need C# events, public class ObjectEventBus. So for these events that are specific to all characters, health changed and death, we'll move those over to the event bus. Just literally cut paste and grab these as well. We got to change the names. So we'll just drop the player and I might say object death and then object health changed. If it's just death and health changed, I don't know, it might be a little bit too concise to be clear, but that's debatable. And then we want to change these invoke calls as well. So we're changing what died and what had its health changed to clarify that it can be used for any object in the game, not just players. So it becomes a lot more universal. All right, and now that I think about it, since we're doing it the Godot way, we do want this to be a resource, which means we need to use the Godot namespace. This becomes a partial class, and that'll allow us to assign it in the inspector. So if we go to the destructible box now, we can do export attribute on public ObjectEventBus. Okay, just as a normal property. And we'll also want the default stats, right? So export public AttributesDefinition, default attributes here, get set. Then on ready, we can create the Damageable component. I might make it public so it can be easily accessed, for now at least. That might change in the future. So if I spell that right, the Damageable component is going to be Damageable component get set. On ready, we create a new Damageable component, and that's going to be a new Damageable component, and we're going to put in the default attributes and the object event bus. Once again, got to spell that right. Okay, so we go over to the Damageable component now, and we want to make sure we pass in the event bus so that we can emit events from inside of here. So let's do the ObjectEventBus event bus. So we'll get that reference to the ObjectEventBus. Actually, since these are already private, we don't need that private keyword here. Then we just make sure the event bus is set here. So event bus is going to be equal to event bus. So we don't need to connect events from here. We just need to emit the events. So then we call the methods on the event bus directly. So event bus, and then we have notify object health changed, I think it was, and then notify object death. Might change that to object destroyed. It's kind of a little nuanced there, what you want it to be. Then the only difference here is we can't queue free directly from inside of here. So you have to do that probably from the node scene itself. So let's say actually we return a Boolean here. So we take damage to the active attributes based on the amount of damage, and we return whether the character is still alive or not. And let's say object here. So we could just do a return, let's say false here, and this will be return true. Okay, so the event bus kind of already gives us one way of notifying when the object's dead, and we can trigger events, and we could connect to that same event from within our object directly. But if we have the Booleans here, then the calling script, which in this case would be the destructible box of the player, would be able to immediately just decide if it's going to queue free or not. So I don't think it's necessary to have the dual paths here, but I think it could be a little nice for the simplicity of it. So here we'll just return attributes.health is greater than 0. And actually, that would be a pretty good helper, because we could apply the same thing here and here. So let's say public Boolean is alive, and that's going to be a lambda expression. We'll just return if attributes.health is greater than 0 or not. Don't need the return here for lambda. And then we could just do is alive here. I guess it would be a little better if it was here. So if not is alive, then we want to notify death. Otherwise, we come here and it's already true. So yeah, I mean, that looks pretty good. In destructible box, you can see I tried to pass in the default attributes resource, but really what we want is the active stats. So let's say private AttributesData attributes get set. We could actually make it public here and then private set. Probably a little better. And we want to pass that in here. So we got in the new damageable component, and I think that name is maybe conflicting here. So let's try damageable equals new damageable component equals a new attributes, new attributes data. And we just pass in the default attributes. Then we create the damageable component from that, and that's going to wire up the event bus for us. So that seems like a lot of work, but now anything that has a damageable component, we can just call damageable component take damage on. So we don't need to recreate the same logic in player.cs. And in fact, inside of here, we just need to do the same thing. We need to make the damageable component. So damageable equals new damageable component. We pass in the attributes, not the default attributes. And then we need the event bus. So we're going to want to probably create that as well. So I might say private object event bus, object bus, get set. And this one's going to be unique to each player. We got to be careful with resources, especially when assigned in the inspector, because if you're not, you're going to get shared references to the same bus between the different players or destructible objects in your game. So we pass that in here. We'll get the damageable component, private damageable component, damageable get set, copy paste the name, just make sure that lines up. And now if we want to take damage, we would just do damageable.takeDamage 10. So we don't need a take damage method on our player anymore. We have a reusable damageable component, reusable attributes data, attributes definition, and a object bus that's in theory specific to each object we have in the game. Now we have to be really careful here because each object in this case actually has their own event bus. So I think we actually want to downgrade the object event bus to a ref counted, and that's how we'll make sure without any editor property changes that these are going to be unique because we'll instance them one per object. So we come in here, we have the object bus here, which has to be initialized first. So object bus equals ObjectEventBus.new. Sorry, wrong language. ObjectEventBus, like that. Okay, now this is unique. But our player context, we still need to feed that those events into the UI. So player context being basically a one-off shared between the UI. That's fine for a single player game. So let's jump into that. And we're going to have a new initialize method here. Public void initialize, where we take an object event bus, object bus. We'll have, yeah, I guess this should be public. Public object event bus, object bus, get private set, and then the object bus gets this object bus, which we define in the player at runtime, right? So this is just kind of wiring between the objects. Now that this is here, we'll be able to grab it from our UI. So let's just make sure the object bus gets created. Okay, we want to initialize the context.initialize object bus here. Okay, hold on. Let me make sure I'm spelling things right. So I'll copy that name back here. Yep, that was the issue. So we initialized the context. The context doesn't work off of the attributes data, so it doesn't need a reference to that. It only triggers off of the events. So all we need is the event bus inside of there. And now on our UI, we go into player log here. We can see the issue here is that those events no longer exist on the context directly. They exist on the object bus dot object health changed, or whatever it was called, and then context.objectBus.objectDef. Now these callbacks, the name's still appropriate because this is the player log, so it's the object health changed event of the player because it's coming from the player context. And if we just update the names down here like this, and if we just copy these events down here, make sure we're unsubscribing from the right events when our player leaves the scene, which is important to do with C# events, then that pretty much is going to be it. So let's go back to Godot. I'm going to hit compile and run. Seems like I did miss one on destructible box. So ready is already called here. Let me see what player does for ready. Public override void ready. I'm just going to copy that. Let's go to destructible box like that. Compile and save. Huh, interesting. I'll reboot the project. Okay, let's compile and run. Okay, I'll cut that. Let's compile. Let's go back in. I'll paste it in. Let's compile. Oh, okay, I see. There's still two versions of destructible box.cs. So let me try moving this into there. Yeah, sometimes the wiring might get out of sync. Okay, so let's compile that. Okay, there we go. So our context, yep, it's going to get the ref counted event bus at runtime. We should be able to hit play. Everything should work fine. So I'm going to hit up, left, down, right, up, down, left, right, up, down, left, right, up, down, left, right. And almost working. Characters are able to go way below 0. So what we forgot here was to check as the return from the take damage is alive equals this. So if not is alive, then we can go to the next line and say queue free, and that should clean up the character after. If we run the game, you'll see the exact resource. Not so much a bug, but just more of an understanding of how resources work in Godot. I press up, down, left, right, and they die at the correct times, but you can see that the player log is not representing it correctly. The player dies, but only once. And the reason for this is that we have 3 players that are trying to share the same resource. So initialize gets called 3 times, but the event bus gets overwritten each time. So it would be representing, in theory, the 3rd player's event bus. So the fix for that is quite simple. In situations, especially like local multiplayer, you might have 2 sets of UI. So having 2 player contexts makes a lot of sense. So you can see I already kind of saved over here as player 2 context to the disk. So you can just click on a player, right click, do a new player context, and then save that to the file system wherever you want. And then you have a new resource that will be unique to that player. So I want to bring the player 3 context to this one. As a safety mechanism, though, if I undo that, then let's say that they're still sharing the same player context. we probably want to catch that because that's a major issue. So if we go to the player context, we can make sure that initialize only ever gets called once. So if I do a private boolean is initialized here, this is default to false, and we'll check if it's initialized already. That would be where this is true. Then we want to push a warning. So gd push warning resource, let's be more specific. Player context already initialized should only have one player initialize per context resource. Okay, so that's pretty clear. And then we could return here so we don't try to do anything else. That doesn't really matter. At this point, we just need to go in and fix the wiring of our scene. So this is pretty important. And then lastly, we just want to say after we initialize, we say is initialized equals true. So this is kind of like a singleton ownership pattern where we just make sure that only one player owns each player context resource, and we don't initialize for any other players that are trying to use it. And we try to make sure each player has their own. So if I hit play here, because player 3 and player 1 both have the same reference to the same resource, we get the warning. But if I change this to player 3 context, now they have unique ones. I'll hit play again, and that warning goes away. We should also see if I move up, down, left, right, then the player log is only going to assign for the first player because it's connecting to that one's events, and we don't get spam from the other players. Now, if you want to turn this into like a multiplayer, local multiplayer player UI situation, then you just need to connect different copies of your HUD to different player contexts. So if I take the player log, I duplicate it 2 times, and let's take player 2 context, assign that here. Player 3 log gets player 3 context here, assign that there. Oh, and I should also move it in the view here so they're not overlapped. So let's move player 3 up to here, player log 2 down to here. Now you have the world's best UI design. Let's do up, down, left, right, up. And you can see that they're each representing their unique players. So there you go, multiplayer UI on a local machine. Of course, you probably want different key bindings for each player. You should start there too. But that solves that problem. Now, there's another issue, which is that the destructible box, you can see we haven't assigned to the default attributes. So this automatically gets caught here because we need the health property set on a null attributes definition. So if we create the attributes definition here, then that'll be fine. But then I remember I haven't initialized the object's signal bus here, which you're not going to see an issue here because we're not trying to connect to the signals yet. But if you're trying to connect to the signals, events, because we're using C# events directly, on this, but the object's null, then eventually that would give you an error. But right now, it's just a hidden issue. We're passing a null into the ObjectEventBus here. So you could do some null checks on the damageable component. That might help. Kind of like this. If you pass in a null to the constructor, then we push an error. That's reasonable. Just some defensive programming. We can also go in here and, well, what you should need to do for it to be correct is to do ObjectEventBus equals new ObjectEventBus. So before the damageable component initializes, we've already created the ObjectEventBus. So that's the fix. You probably want to start considering test coverage. So, if you want to add unit or integration tests, then Chickensoft Godot test is a good option to do for that. That's what I use. And that could help reveal issues. Like you could check that after it's on ready that all of these things are initialized with all the dependencies properly. But the quickest way is probably just to, have these kind of checks where you make sure that what's being passed into here is not null if you expect it to not be null. So this becomes a runtime check. But anyway, if we compile and run, everything should work fine here. We get 4 attributes data initialized because remember we have the destructible box here. We have the 3 players, and this is 2 different types of game objects, but they are reusing those attributes components. So this is definitely an improvement from where we started at the beginning of the video. Some considerations you might want to think about going forward is each of the box components, they do have their own event bus, right? But that's unique to that specific object. So you might think about having some kind of manager where, let's say all of your game entities have a component that make them register themselves with the game combat manager, we could say, and then that will handle all of the events for all of the objects in the game. So if you need to represent any object took damage inside of a game log, then you would do that through the manager. Okay, but hopefully in this video I've demonstrated how you can extract parts of your code out to reusable components like attributes or like a object event bus to be less specific to specifically one type of node like your player, but more reusable across things like NPCs, destructible objects, and players altogether because they share reusable logic. So that's going to be it for this video. Thanks for watching to the end, and I will see all of you in my future video content.